Hello students, in this video I am going to explain splay trees. We are at the last part of the unit 5 advanced trees. Up till now what we discuss is the threaded binary tree, AVL tree, red black tree, B tree and B plus tree. All these trees have its own advantages and disadvantages. AVL tree, red black tree, B tree are the variants of the binary search tree. These are used for efficient retrieval of data or for efficient searching. In the same line, the splay trees is another variant of binary search tree. In a splay tree, recently accessed element is placed at the root of the tree. Splay tree is a self-adjusted binary search tree in which every operation on element rearranges the tree so that the element is placed at the root position of the tree. I repeat, splay tree is a self-adjusted binary search tree in which after every operation on element, it rearranges the tree so that the element which is recently accessed is placed at the root position of the tree. In splay tree, every operation is performed at the root of the tree. All the operations in splay tree are involved with a common operation called splaying. Splaying is a technique similar to the rotation in AVL tree. Unlike AVL tree, splay tree do not have balance factor for every node. In AVL tree, the balancing is done with the help of balance factor, but in a splaying tree, it doesn't use the balance factor for rotation, but it uses a technique that is splaying, which is very similar to the rotation technique in the AVL tree. Let us take an example of searching on a splay tree. The search operation in splay tree does the standard BST search. Standard BST search means if I want to search a particular key K, you are comparing it first with the root node. If it is less, then you are traversing the left subtree. If it is greater, then you are traversing to the right subtree. So the basic operation is same, but the change is that in addition to the search, it also splays or move a node to the root. Means if I am doing a search on a key K and I found the key K at some location, then the splaying is automatically done and that node or the key that I am going to search is become the root of the tree. If the search is successful, then the node that is found is splayed and become the new root. If the search is unsuccessful, then the last node accessed prior to reaching the null is splayed and becomes the new root. Then next operation is insertion and deletion. When an atom X is inserted as a leaf, a series of tree rotations bring X as a root. The deletion operation in splaying tree is similar to the deletion operation in binary search tree. All of you know that there are the three cases in the deletion operation of binary search tree. What are that three cases? The first case is that you are trying to delete an atom that has no child. Means that is a leaf node. Second case is you are trying to delete a node which has only one child. And the third case is you are trying to delete an node which has two children. Okay, so the same deletion operation, the same cases you are applying in a splay tree. But the difference is that before deleting the element, we first need to splay that element and then delete it from the root position. Means, first search that element in a tree. When you found that element, you move that element through the splaying technique, you bring that node to the root and then delete it from the root position. Means here you are dealing with the third case, that is the node which has two children. So finally join the remaining tree using a binary search tree logic. So what is the logic when you are deleting a node with two children? You are replacing the node that you want to delete by the in-order successor, or you are using the minimum from the left side. Then, what are the cases for splaying? So, in the splay tree, what is important? The important is the splaying technique. So, there are the different cases for splaying. The first is search a node is a root, then return X and no splaying. Suppose if you are trying to search a node and that node is present in a root or which is same as the root node, then there is no need of splaying. Okay, so simply return the X. Second, ZigZag, that is zig or zag, means search a node is a child of root, means that X has no grandparent. You are trying to search a element X which is a child of the root. Then you perform a zig or zag. Third case, you are trying to access a node which has both parent as well as grandparent, means which is at the next level, that is third level might be. So in that case, you have to perform ZigZag or ZigZag operation. Node is left child of parent and parent is also the left child of grandparent. Then you need the two right rotations, that is ZigZag. Or node is a right child of its parent and the parent is also the right child of grandparent. Then two left rotations are required, that is ZigZag. Then ZigZag, it's a combination. Node is a left child of parent and the parent is a right child of the grandparent. Or node is a right child of its parent and the parent is a left child of the grandparent. So here when there is a crossing, okay, then you have to go for the cross rotation, ZigZag, ZigZag. Okay, so here there are the main three techniques, ZigZag, ZigZag. Okay, so let us see what is this ZigZag rotations. You have to remember this in a simple language I am explaining you. That zig means a right rotation, zag means left rotation. When I use the word zigzag, it's a double right rotation. ZigZag means double left rotation. ZigZag means right left rotation. Zig means right, zag means left. So it is very easy, right left rotation. Zag zig means zag is left and zig is right. So you have to remember only the terminology. You know the rotation technique. You have to apply the same technique here, but you have to only change the names. Instead of saying the left right rotation, we are calling it as ZigZag or ZigZag likewise. Okay. I'll demonstrate a simple example here. Suppose X is a node that I want to access. Okay, I'm searching for a X and it is a left child of the root node, that is Y. First case, right? So here you are applying the zig operation. Zig means right rotation. So X is moving, shifted to the right side, the Y is moving down and C is also moving down. So X become the root node. Now next is double rotation. This is an example of double rotation where the x parent is on the left side, its grandparent all are in the left side. Okay, if you observe x, y, z all are lying in the left side. So here you are performing double right rotation, zigzag rotation or zigzag splaying. So here x is moving as a root node. So here our main aim is to move the recently accessed node as a root node. Okay, so accordingly you have to choose the splaying technique. This is the third scenario where z left child is y and its right child is x, and you want to move this x to the root, right? So it is a cross. X parent is y and y's parent is z. So it is the left child, y is the left child and its right child is x. So you can't use a single rotation, you have to double rotation with the combination, like you have to shift it to the right and then left. So zigzag rotation. So you have to move first x to the left and then you have to move it to the right side. So finally you are moving the x as the root node. So this is nothing but the splay trees. It's very simple. Okay. So I'll demonstrate the animation of this splay tree on this site in the next video. Okay, here you can visualize the splay tree, how the splay tree is constructed, how the delete operation, search operation is performed on the splay tree. Thank you.